Today we're going to learn about tangent lines, and a tangent line on this diagram is GF. GF is the tangent. And how I know it's a tangent is because it touches the circle in one point. That's here at point G. And it's on the outside of the circle, so kind of like hits the circle on the outside. And the really important thing about a tangent line is it is perpendicular to the radius. So if I draw a radius to where that tangent line hits, it makes a 90-degree angle. And that's super important because that shows us that this shape right here is a right triangle. So a lot of times with tangent line problems, we're going to have right triangles. So let's look at this first one. FG is tangent to the circle H, HG is 5, and HF is 13. Find FG, this piece. Well, I know that the tangent line makes a right angle, so I have a right triangle. So just like with right triangles, I could use Pythagorean theorem, SOHCAHTOA, trigonometry. I could use special right triangles like 30, 60, 90. But if I have two sides and I'm trying to find a third, I just want to use Pythagorean theorem. Now it's important that I label this 90-degree in between the tangent and the radius, because that will help me find my hypotenuse. So my hypotenuse is across from the 90, it is 13. So that's the side that's by itself squared. That's your C. So it's 5 squared plus x squared equals 13 squared. Then you would just solve for x. So the first key idea is that we have right triangles when we have tangent lines. And then we could use what we know about right triangles to solve. Going down a little bit for the second big key idea, is that if I have a tangent line here that's hitting two circles, so CD is the tangent line, I know it's going to be perpendicular to this radius, and it's also perpendicular to this radius. So I have two 90-degree angles. So if I look at these two triangles, they don't look equal to me. So there is a relationship though, even though they're not equal. They're both right triangles, and these angles are the same because they're vertical. So if I have two angles that are the same, I know that the triangles are similar. Because we learned a couple units ago that if two angles are the same, we have similar triangles. And if I have similar triangles, I could set up a proportion. So here's my first radius. It matches up with a radius 2. So if I want to make my proportion, I want to make sure I have corresponding or matching sides. So the radius 1 over radius 2 equals the tangent line for 1 and the tangent line in triangle 2. So from C to E is T1 over DE, which is tangent 2. So those are similar triangles, and we could use those ratios to help us. And for some reason, if we had this side, this is the hypotenuse. This is the hypotenuse. I could do it equal to hypotenuse 1 over hypotenuse 2 if they give it to us. So it's just got to be the corresponding sides when we make that proportion. All right, pause. Let's go on the inside left and actually do an example with some x's and numbers. I've already labeled the diagram, and they tell me that A to B is tangent to circle P and Q. So this line here, AB, is tangent. So I know I have 90-degree angles when it hits that radius. I also know that these are vertical angles. So my relationship is I have two similar triangles. The triangles are similar. And I know this because I have two angles the same. So again, if I have similar triangles, I could set up my proportion. So it says find perimeter of triangle APZ. That's this triangle here. But to find that perimeter, I first need to know x. So let's set up a proportion to solve for x. I see that my first radius is 6. My other radius is x. So 6 over x equals, my first tangent line is x plus 5. And notice when I set up my next proportion, I started with the 6, the big triangle, divided by x, the small triangle. So I need to start with the big triangle tangent line, x plus 5, divided by the small triangle tangent line, 4. So now that I got my proportion set up, I could cross multiply to solve. So 24 equals, don't forget to put parentheses and distribute, x squared plus 5x. When I have an x squared in my equation, I usually want to end up factoring. Before I can factor, I got to get one side equal to 0. So I get 0 equals x squared plus 5x minus 24. I need to factor here. I need two numbers that multiply to negative 24 and add to 5. That's positive 8, negative 3. That would multiply to negative 24, add to 5. And then I just got to solve for x. So if x plus 8 was to get it equal 0, I would subtract 8 from both sides. X equals negative 8. And then I would add 3 to both sides to solve for this one, and x would equal 3. Now, if I was going to plug in an x value, I see that BQ is equal to x. It would make no sense if that side was negative. So I'm going to use 3. So now I want to find the perimeter of triangle APZ. So I need to find the perimeter of this triangle. APZ is here. Well, I see that one side is 6, and I have x is 3. So 3 plus 5, this side is going to be 8. So I have two sides of this triangle. Let me just draw it out really quick so you can see what I'm talking about. This side's 6, this side's 8. Just drew it so you can see better. I need to find this missing side. It's actually not x. I shouldn't do that. Let's just call it PZ. So I want to find PZ. I know that this is a right triangle. So to find a missing side, I could use Pythagorean theorem. So I'm trying to find this side, PZ. So 6 squared plus 8 squared equals PZ squared. 6 squared is 36, 8 squared is 64. 64 plus 36 is 100. To get rid of the squared, I take the square root of both sides. So 10 is equal to PZ. So this side's 10. So my final answer for the perimeter of triangle APZ, now that I have all three sides, 6, 8, and 10 adds up to 24 units. So that's my perimeter of my triangle. Pause the video, try the one on the right on your own. I'll show you the answer in a second. So on this problem, I'm trying to find EB. I got all my sides labeled. What I can't do, which I saw someone do in class today, is call this side X. I know that's the side I'm trying to find, but that's like saying this side is equal to this side if they're both X. That's not true. So you can't just put an X there. So you got to think about what you need to find. First, I have to solve for this X, and then I'll be able to find this missing side. So since they're tangents, I know these are right triangles, and those are vertical angles, so those are two similar triangles. So I can set up my proportion. So X, the radius of the small triangle, over 4, the radius of the big triangle, equals 4, the tangent of the small triangle, over X plus 6, the tangent of the big triangle. Then I just got to cross multiply and solve. So I need parentheses here. X squared plus 6x equals 16. Subtract 16 from both sides. X plus 6x minus 16 equals 0. X plus 8 is my factor, and x minus 2. So that multiplies to negative 16 and adds to positive 6. So x equals 2 or x equals negative 8. Would it make sense to have a negative side here for CA? So x is 2. All right, now if I want to find this missing side, EB, that's what the question is asking for. Now that I know my x, this side is 2 plus 6, which is 8. So that's my hypotenuse of a right triangle here. So I'm going to do 4 squared plus 8 squared equals, I'm trying to find side EB. 4 squared 16, 8 squared 64, add those together, you get 8. Solve by taking the square root of both sides. So EB is going to equal square root of 80. But it also says simplest radical form, so I want to make sure I'm breaking down the square root of 80. I could do 16 times 5 would give me 80, and I could take the square root of 16. The square root of 16 is 4, so it comes outside the radical. I can't take the square root of 5 with an even number, so I'm going to leave it inside the radical. So EB is equal to 4 radical 5. So we found that missing piece.